To solve radical and rational equations, we're going to have to use our understanding of solving simpler algebraic equations. There is a set of, I should say, steps that you would use to solve a radical equation. And the first step in solving a radical equation is to isolate the radical. That means that you need to get the radical all by itself. Here's the radical. Anything that's not under that radical or inside that box has to go away using your general algebraic skills. Well, what has to go away is the 5 because it's not in the box. We get rid of it by subtracting it. The reason we're subtracting is because it says 5 plus the square root. Alright, so now I'm left with the square root of 3x plus 4 equals 5. Once you've isolated the radical, the second step in solving the problem is to get rid of the radical. Now we started with the simplest type of radical, which is the square root. We get rid of the square root by squaring both sides of the equation. Remember that we can do anything we want to an equation as long as whatever we do to one side, we do the exact same thing to the other side. Now the square and square root, they cancel each other out, so now you're left with 3x plus 4 equals 25. Your last step in the process of solving is to solve your general algebraic equation that you're left with. I call it a general algebraic equation because you're left with a two-step equation. Remember, we're solving for x. So if I'm solving for x, then I have to get rid of stuff in a particular order. And the order in which I have to get rid of stuff is first I have to subtract this 4, because you always look for anything you can add or subtract from both sides. Then I can get rid of the 3. And I find out that x equals 7. Before we move on to problems that have rational exponents, let's go back to what we already know. We learned that the problem, the square root of x equals 36, is the same thing as the problem x to the 1/2 power equals 36, because the square root and raising to the 1/2 power were the same. Well, this problem here, we would solve both sides by squaring. So x is equal to 1,296. Well, if these two problems are the same, and I would literally do the same thing, look at what happens in the second equation. The properties of exponents tell us that when we raise a power to a power, we multiply those exponents together, and 1/2 times 2 is 1, because they're reciprocals. And one thing we know about reciprocals is when you multiply them together, you get 1. So we end up with x is equal to 1296. So the way that we're going to go about getting rid of rational exponents, I believe we always use m over n, is we're going to raise it to the reciprocal of its exponent. So let's try a problem now that has a rational exponent in it. And the rules for solving it are the same as the rules for solving radicals, because a rational exponent really is just a radical. We want to isolate this. That means anything that's not in the parentheses goes away. So I have to get rid of the 3. This 3 goes away by division, not subtraction, because the 3 is being multiplied by the parentheses. So now I'm left with x plus 1 to the 2/3 equals 4. Well, now that I've isolated my rational exponent, to get rid of the rational exponent, I have to raise both sides to the reciprocal of the original exponent 2/3. Well, the reciprocal is 3/2. These always multiply together to give you 1, in which case they just cancel each other out. And then 4 to the 3/2 power, that's the same as the square root of 4 cubed. So that's 2 cubed, which is 8. And then you're just down to a general algebraic equation, which you're going to solve by telling me it's 7. Let's try another radical problem, one with a different radical rather than a square root. So remember we said that when we're dealing with radical equations, we want to isolate the radical. The number one reason we want to isolate the radical rather than just trying to go ahead and get rid of the radical is because you'll end up with a much more complicated problem if you don't just isolate the radical first. Now, what's the process of isolating the radical? Remember, think about this problem here as if it were 3x plus 1 equals 25. What would you do first to solve for x? Well, you should subtract 1. We always look for things that we can get rid of by adding or subtracting. So now I'm left with 3, the fifth root of x plus 1 to the third equals 24. Now I can get rid of the 3, and it has to go away by division. So now I'm left with the fifth root of x plus 1 to the third equals 8. Now, our property of radicals said that if you had, let me rewrite that, the nth root of a to the m power is the same thing as a raised to the m over n. It turns out this problem is a little bit nicer looking if we convert this to a rational exponent. And the rational exponent would be 3/5, because the root index always goes in the denominator and the exponent always goes in the numerator. So now, how do I solve this? Well, we just said a few moments ago you solve it by raising both sides to the reciprocal of the exponent. So the reciprocal of 3/5 is 5/3. On the left-hand side, the 3/5 times 5/3 is 1. It goes away. On the right-hand side, this is the same thing as saying the cubed root of 8 to the 5th. The cubed root of 8 is 2, and 2 to the 5th is 32. And then you're down to a general algebraic equation, which you can solve by simply subtracting 1. And you find, oops, sorry about that. You find out that x is equal to 31. To do an application problem, let's work with a formula we've seen before. This is a great problem to use when we're talking about solving radical equations or using radical equations. The formula for the volume of a sphere is v equals 4/3 pi r cubed. Let's solve this equation for r. The previous problems that we did with this formula, I solved it for you. Well, let's think about this. I want r to be by itself. That means the 4/3, the pi, and the cube all have to go away. But in what order? Well, let's get rid of the 4/3 first. The 4/3 and the pi are both being multiplied, so how do you get rid of multiplication? Well, you get rid of 4/3 by multiplying the other side of the equation by its reciprocal. So you'd start by multiplying by 3/4. We'll call that 3v/4 just to make it look a little bit nicer. Then we're going to get rid of pi. Remember, we still want r to be by itself. We're going to wait till the very end to get rid of that cube. We have to do that because it's attached to the r, which is what we're solving for. So to get rid of pi, you would divide the other side by pi. Dividing by pi is the same as multiplying the other side by its reciprocal. Well, what's its reciprocal? 1/pi. So now we have 3v/4pi equals r cubed. Now I need to get rid of the cubed. How do you get rid of a cube? You cube root both sides. And we end up finding out that if we wanted to find the radius of the sphere, if we knew its volume, we would do the cubed root of 3v/4pi. Now let's go and use this formula to find the radius of a sphere whose volume is 51 cubic meters. So, the radius is the cube root of 3 times 51/4pi. Now, however you want to go about doing this problem, is, I don't care. The way I would do it is I would evaluate the part that's under the radical and take its cube root, and I would do it all in the calculator so that I never have to round anything off. However, you may feel more comfortable multiplying the numerator and then multiplying the denominator and writing a rounded off value, 12.57, and then doing 153 divided by 12.57, which is going to give you approximately 12.17, and then taking the cube root of 12.17 and getting approximately 2.3. And the units of the radius are meters. Radius is a length, so it's in linear units. Volume is always in cubic units, which is why the original volume was 51 meters cubed.